Please note that this is actually the second video for the use of QM for Windows for the examples for chapter number 12. So you want to watch the first part first, but I ran out of time. So we were up to number 20. Number 20 was asking me to calculate the amount of inventory that I need to have on hand, given that my daily demand is 600 pounds, my standard deviation on the daily demand is 52 pounds, and my stock out risk is 4%. So I'm going to determine my reorder point here with safety stock with normal distribution. So again, that's problem number 20. And I'm going to go ahead and hit OK. And my daily demand was given as being 600 pounds. My daily demand, daily demand, 600 pounds. My standard deviation on that daily demand is 52 pounds. The service level that I require is basically, since I can accept a 4% stock out risk, that means that I want to service 96% of the time, so I put in 96. Note that again I have to put in 96 because it asked me for the percent, and I can go ahead and hit solve. What I need for this one here, it requires me to put in a lead time, so I'm just going to put in 1 day, and I'm going to go ahead and hit solve, and it tells me that my reorder point is 691 units, right? So 691 units, my safety stock is actually 91 units. Alright, the next problem is number 22. For problem number 22, I can't actually use any of the tools directly for QM for Windows or QM for Excel. So I'm going to jump right to problem number 27. So I'm going to close this file. And I don't want to save it. File number 27 says Ned's Natural Foods sells unshelled peanuts by the pound. Historically, they've observed daily demand to be normally distributed. So note normally distributed, a mean of 80 pounds and a standard deviation of 10 pounds. Lead time appears also normally distributed with a mean of 8 days and a standard deviation of 1 day. What reorder point would provide a stock out risk of 10%? So for that one there, I'm going to use the reorder point with a safety stock for the normal distribution. So I'm going to say this is going to be problem number 27. Okay, and my daily demand is given as being 80 pounds per day. My standard deviation on that is 10 pounds. My service level that I desire, in this case here, I wanted to have a stock out risk, number 27, the stock out risk that was acceptable was 10%, so that means that I want a 90% serviceability amount, and my lead time is given as being 8 days with a standard deviation of 1 day. So I can go ahead and hit solve, and that tells me that my my safety stock is going to be 108, and my reorder point is going to be 748.61, rounded to 749 units. Right? Alright, so we have another one to go over, problem number 39. Problem number 39 is on page 552. It says Burger Prince buys top grade beef for $1 a pound. A large sign over the sign guarantees that the meat is fresh daily. Any leftover meat is sold to the local high school cafeteria for 80 cents a pound. 4 hamburgers can be prepared from each pound of meat. Burgers sell for 60 cents a piece. Labor, overhead, meat, buns, and condiments are 50 cents per burger. Demand is normally distributed with a mean of 400 pounds per day and a standard deviation of 50 pounds per day. Now note the normal distribution on this one. What daily reorder point is optimal? Hint, it says shortage costs must be in dollars per pound, because we're doing everything in terms of per pound on this one. So for this one here, we're going to use the single period model with normal distribution. So I'm going to close this file that I have open right now. File, close, and I'm not going to save it. So again, I'm going to do single period with a normal distribution because that was given as being a normal distribution. And this is problem number 39. Now in this case here, I'm going to change it to marginal loss and marginal profit. Reason being is because I really only have marginal loss and marginal profit per pound of beef because I'm given information per pound of beef, actual total cost of per hamburger. I'm not given information for the what makes up the individual cost, so I'm going to have to do marginal loss and marginal profit on that one. All right, so I'm going to hit OK, and my parameter, my marginal profit per unit, my marginal profit per unit of beef. Note that each pound of beef, each hamburger, I should say, sells for 60 cents per pound. And each hamburger actually costs me 50 cents for the burger itself. So that's 10 cents per pound, or per burger, I should say. It costs me 50 cents per burger to make, times 4 burgers per pound. So I'm going to basically have a marginal profit per burger, I get 40 cents per pound. So again, it's each burger sells for 60 cents and it costs me 50 cents to make, so I make 10 cents on a burger and 4 burgers per pound. So my marginal revenue is 40 cents for each pound of burger. My marginal loss, remember that my cost for hamburger is $1 per pound. Everything is in pounds, and if I'm going to actually sell it for any salvage value is going to be 80 cents. So my marginal loss per unit is going to be 20 cents per pound, right? And I have a mean distribution of 400 pounds per day, and I have a standard deviation on that of 50 pounds per day. So I'm going to go ahead and hit solve, and it's going to tell me that I have an optimal order quantity of 421.533 or 421.5 pounds of beef. That's the optimal amount that I want to have on hand. All right. I hope that these were somewhat helpful to you to go over. And I have one more here that's actually in the problem set, number 38. Number 38 says demand for Devil's Food whipped cream layer cake at a local pastry shop can be approximated using a Poisson distribution with a mean of 6 per day. The manager estimates it costs $9 to prepare each cake. Fresh cakes sell for $12. Day-old cakes sell for $9 each. What stocking level is appropriate if 1/2 of the day-old cakes are sold and the rest of the are thrown out? With the information that's given on that one, it's really not possible. I have to kind of do a trial and error approach on this. I can't really use QM for Windows or QM for Excel for this one here. All right, so that's going to be it for the examples for this one. And again, you can use similar items for QM for Excel. Notice again that if you want to use these for your homework, you're going to have to do screen prints and attach those to your Word document. And you're going to have to label each individual item. All right, thank you so much.